Okay, wonderful. Whoops. Okay, great. Well, thank you so much, everybody, for taking a little bit of time to learn about our hydrofoils and what we've accomplished over the last several years. My name is Jason. I'm the founder of Hydrofin, and so I'm going to just kind of step us through this conversation here. And you guys, please feel free to interrupt me at any point if you have questions. I'm happy to stop and answer those questions as we go along the way. I've got about 45 minutes, I would say, of content prepared here. And then, of course, time for questions at the end as well. So let's just jump into this. So just a little bit about myself. So I'm the founder of Hydrofin, really just passionate about boating. So I've grown up on the water, probably have 40 years worth of experience of owning and operating a boat. Actually started digging into this about 5 years ago. And so my background is basically I like to offshore fish. And so we would run these long range trips where we go offshore 50 or 100 miles. And so on those trips, it was all about fuel economy, efficiency, how far we could go. And so on some of those trips was just convinced that there was a better way to boat basically and be more efficient with boating. And so started to research hydrofoil technology. And so that's what led me here to Hydrofin. Last year, we were fortunate that we went to the IBEC show and won the Innovation Award for propulsion systems at that show. And so we'll talk a little bit about what that system includes. But also, so our design engineers and partners kind of behind the scenes for Hydrofin is a company by the name of Morelli and Melvin. And so I work directly with Pete Melvin on this project. And so Pete has been instrumental in really designing and creating the system. So I came to him with the concepts and with the ideas and had done some prototyping and some design work up until the point where I met with him. And so really his team kind of helped me create the application or create the products that we've got today that we're gonna talk about. But Pete and his team, so they've won multiple national and international design contests and racing championships. So they won the 2010 America's Cup. So they were the design team behind the America's Cup in 2010. And then in 2013, they were the runner-up. And then in 2017, also the runner-up for winning the America's Cup. Only at that time, they were with Team New Zealand. So very credible organization. And so very fortunate that we've got the opportunity to work with Pete and his team. So first, let's talk a little bit about the problem. So what we're looking at, so from a Hydrofin perspective, but yeah, the problem is, it's the same across the board as it relates to boating, is that drag kills, right? So it kills speed, it kills fuel economy. In a lot of cases, it kills the ride and the performance. And so that's really what we're focusing on. And so for our applications, what we've done is we've got a couple of different patents on hydrofoil technology specifically for pontoon boats. And we focused on pontoon boats because they're the #1 selling boat in the nation. And so there's about 60,000 brand new pontoon boats sold each year and about 1.5 million registered pre-owned pontoon boats out there in the market right now. And so for pontoon boats as well, so they're displacement holes, they're not planing holes. And so drag was a particular problem for these boats. And so you guys have probably seen them out on the water. And so with the exception of some super high powered pontoon boats and tri-tune boats, they really just aren't very efficient boats. And so that's what we kind of set out to solve the problem of drag for pontoons and tri-tunes. And so that's what we're going to be talking about mostly here today. And so as we look at what the consumer options are prior to Hydrofin, really the best options and so the most common options are big motors. And so again, you guys have seen this. So, companies are solving drag problems with high horsepower, right? And so it's not uncommon now to see tri-tunes in particular with 300s, 350s, 400s, and even in some cases now twins. And so we're seeing a common trend for high horsepower engines. But the problem that I see with that, I think a lot of consumers see with that, is that they're very expensive. I mean, so the average tri-tune today is about $90,000 to purchase a tri-tune. And some of these boats are getting up into the $250,000, $300,000 range. And so it's not a family boat anymore. There's a lot of people that just simply can't afford boats with those types of price tags. And so that's a major problem, right? And so, again, our goal is to kind of solve the problem at a lower cost point, but still with a high performing boat. So the number two, I guess, consumer option would be as a tri-tune. So a lot of boats, especially back in the 90s and probably early 2000s, were double log. So, traditional bitunes or pontoon boats compared to what is more common today, which is a tri-tune. So it's got the 3-log solution. And so that certainly solves the buoyancy problems that were inherent with bitunes, but it doesn't necessarily serve or solve the drag problems, because the truth is that with middle logs or with tri-tunes is you're adding weight and you're adding drag to the boat. And so that's why higher horsepower was needed to push those boats. If you put equal horsepower on a bitune and on a tri-tune, the tri-tune is actually going to be a little bit slower because the boat's heavier and it's going to have more drag to it. And so that's why they started putting, bigger motors on these tri-tunes. And so the number three, I guess, option for, and this is more true from a tri-tune perspective compared to the bitunes, but is a lifting strakes. And we'll talk about that a little bit more in the presentation. But lifting strakes are simply, it's an extruded piece of aluminum that they weld to the bottom of the boat. And it's supposed to act as a planing surface to help generate additional lift on the log itself. And so it's kind of a controversial subject. I mean, so there's a lot of variables that impact how effective the lifting strakes are. Of course, with a higher horsepower motor, the lifting strakes are going to be, much more effective, but those boats are getting up on plane anyway. And so we'll kind of talk about that. But the reality is, at least from our perspective, is that the current offerings, they're more workarounds. They don't necessarily solve the drag problem. They're just workarounds to the drag problem. We're just really adding horsepower to power through drag and to make these boats plane. And so that's really what we're going to be focusing on here in this conversation. Okay, so these are just a couple of snapshots of what the products look like. So what we've developed here is a couple of different, we've actually got 3 different hydrofoil solutions that are made for pontoons and tri-tunes. And so what we're doing, as you can see in the pictures here, and we'll go into this in more detail as we get into the presentation, but you can see in the picture here, so we've got 4 different hydrofoils that are mounted to each boat, regardless of whether it's a double pontoon or a tri-tune. And so that's the system here. You can see there's 2 main foils that do the majority of the lifting. And then there's 2 rear foils that basically stabilize the boat while it's in flight, so to speak. And so this picture here, similar, you can see that we've got a strut. So we're basically lifting the boat with these main foils here. And the lifting force and the weight is distributed across this large curved plate that matches up to the same diameter of the hull of the boat. And then it's also spread across this strut that is mounted to the deck of the boat. And so that's for our double pontoon boat system. So for tri-toons, it's a similar design, except we had to change it. We couldn't put the struts here and these upper supporting brackets on the boats because of this interlog and the space that's required in between here. And so we redesigned the hydrofoils for tri-toons. And so the shapes are a little bit different here. And the load capacities and what the lifting force is a little bit different as well. But we'll get into that as we get into the presentation. So I'll just pause here real quick. Are there any questions so far?
Jason? Question?
Yeah, sure.
What type of adhesive are you using to stick these things on the hull?
Yeah, that's a great question. So we're not actually welding this. So this plate right here and this rear plate on this picture. So we're not welding these. Of course, they could be welded. So if we begin to work with a manufacturer, that's certainly an option that they could pick up and choose. But from our perspective, so we're selling these and we're installing these directly to consumers. And we're using a structural adhesive. And so the structural adhesive that we're using right now, it's a Plexus product. It's the MA 8120 product. And so it's got a lot of the same characteristics as welding after it's fully cured. So the cure strength on this product, it's about 3,000 PSI after it's actually cured. And so it creates actually a chemical bond to the hull of the boat. And so it etches into the similar material. So all the products that we're using are aluminum products. So this is 6061 T6 heat treated curved plate, and it's matched up to the hull of the boat. And so that's the structural adhesive that we're currently using. And we've had phenomenal results with it. We haven't had any of the parts fail. And we've had this on boats now for about 1.5 years, and we've got it on about 200 boats around the country. Any other questions about that topic or any others?
And the question is, how long does it take to cure?
Okay, so in terms of the installation, like how long does it take to cure? Is that the question?
That's the question.
Yeah. Okay. So basically the product, so the work from a working time perspective, there's different material types from Plexus, but on average, it's between 15 and 20 minutes is the actual handling time. And then it sets up within an hour, it's at about a 70% strength. And then in 5 hours, it's at 90% strength. And in 24 hours, it's at 100% strength. And so in a lot of cases, we'll actually, if we start early in the day, we can actually install the product and put the boat back in the water and test it the same day, as long as we've let that 5 hour cure time, once it's at 90% cure time, we've got enough surface area on these plates that we can run the boats without problem. And like I said, we haven't had any failures on it. And so it's fantastic because we can actually complete this job in a single day. The actual complete install time on this system, it's about 6 to 7 hours, depending upon the experience level of the installers. But basically, and it does require 2 people to install the system, but still 6 or so hours, and that customer is back on the water the next day and running their boat. So it's not a super invasive process.
Excuse me, what's the name of the product again, please?
The question is, Jason, what is the name of the product?
No, the adhesive.
The structural adhesive, and I can send this to you guys. Unfortunately, I meant to put a picture of the product, but the company, it's ITW, and the product is Plexus. So it's PLEXUS. And the specific product number, it's M as in Mary, A as in Alpha, 8120.
Thank you.
Yeah.
boat still trailerable?
The question is, are the boats still trailerable?
Yeah, they are still trailerable. It's not a problem. You can see in this picture, the hydrofoils are mounted on this, or the boat sitting on the trailer. We'll talk about that a little bit further in the presentation. There are some considerations to make as it relates to the installation location for the hydrofoil. So I'll kind of keep some additional comments to a later slide on that topic.
Thank you.
Randy, they asked, does it increase the draft?
Yes, yeah.
Yeah,
Yeah, and so I'll keep that question also. I tell you what, I'll go ahead and move forward on this. There's a couple of questions. I know these pictures introduce probably a lot of thoughts. So kind of hold some of these pictures in your mind. We can certainly come back to these, but we will talk about trailers and we'll talk about draft in some of the following slides here. Okay, so as we get into this, let's talk about what's the lifting force that is created by the hydrofoils themselves. And so this chart here, let me just explain this chart. On the bottom of the chart here, so what we've got is we've got the angle of attack. And so with the system, without going into the technical details of it, in summary, we've got the ability to change the angle of attack, which is determined during the installation process. And so the installer would actually look at some stats of the boat. So they would look at the boat weight, the speed of the boat. Those are the two most important factors. And based upon the weight and the speed, we've got a chart that we provide to the installers that would determine how much lift is required for the boat. And so typically what we look at is we want to set up the hydrofoils so that they lift between 40 and 50% of the total weight of the boat. We don't, if it's less than that, we don't get the performance gains that we're looking for. If it's more than 50% of the total weight of the boat can actually have some adverse performance effects. The hydrofoils will actually start to lift the boat out of the water in certain situations, and it can cause porpoising. And so it is important that the installer understands that and follows the charts that we provide in the installation, recommended installation methods that we provide to keep it within that 40 to 50% range. But you can see here, so if we just take 30 miles an hour as an example, the capabilities of the hydrofoils, let's say at just a 0 degree angle of attack. So if it's just a neutral angle of attack, we're generating at 30 miles an hour, it looks like it's around 1,600 pounds of lift. And so that's what each one of these lines represents, is what's the angle of attack and what's the lift force that's generated on this. Now, most boats, at least, so this product chart here, by the way, it's not indicated on here. We have a couple of different products. This is the lift chart, or what is called our Superfly product, which is made for bitunes. Most bitunes are limited, by a horsepower of about 150 horsepower. So most bitunes are probably traveling max speed up to about 35 miles an hour. And that's why this lift chart kind of caps out at 40. But you can see, I mean, even up to, a plus 2 or 3, we're able to generate, in excess of 3,000 pounds of lift. Now, most bitunes are not that heavy. There are some bitunes that have like either some of the older boats, like we do see some boats that are, 25 or 28 foot, and some of them have the upper decks on them, so it's like a double deck with a slide and those kinds of things. So some of those boats might require some of these higher angles of attack, but most of the boats that we see are, on average, probably going to be a, 2,500 pound boat or maybe a 3,500 pound boat. So our angles are typically in the 0 range or a +1 or -1. So, but this just gives you an example of the type of lift that we're looking at. So we do have designs again for bitunes and tritunes. We've got 3 different foil sizes. So it's kind of like propping a boat in a way too, is we do have different foil sizes for different boats and applications. And so those angles determine how much lift can be used for the different foil sizes. And we've got pre-made hardware to fit on different boats. One fortunate thing from a pontoon boat perspective is that there's really only 3 different log sizes. So across all the different, there's over 20 different boat manufacturers out there, but across all of those different boat manufacturers, there's only 3 different log sizes. They're really 24-inch logs, 25 or 27-inch logs. And so we've made hardware to fit perfectly against any of those different log sizes. So effectively, we can put this system on pretty much any boat. And so the net benefit of what it does for the boat. So when we talked about that lift fraction of, we want to lift about 40 to 50% of the weight of the boat, what that does for the boat itself is that generates somewhere between 6 and 12 inches of lift in the bow of the boat and 3 to 5 inches of lift in the stern. And so that's, again, it's dependent upon how heavy is the boat, how fast are you traveling when you take these measurements, how many people or gear is on the boat. But on average, what we see, we should be able to see anywhere from 6 to 12 inches in the front and 3 to 5 in the back. And so that translates into substantial performance and efficiency gains, with these foils. And so we'll talk a little bit about that on this slide here. So typically for bitunes, we see the most radical improvement on bitunes. We don't see quite as much on tritunes, but from a speed improvement perspective, it ranges, and it's not uncommon. I would say our average is probably about 25% speed improvement on a bitoon, but we've actually seen up to 60% speed improvements on bitunes. And what that translates, because most bitunes, keep in mind, most bitunes travel, they're not super fast boats. They're going between 20 and let's say 35 miles an hour. So that translates into a 6 to 9 mile an hour speed improvement on most boats. And so in addition to that, and a lot of pontoon boats don't have fuel flow meters, but for the ones that have, some of the newer boats that we've tested on, and we've got this on over 100 bitunes, and new bitunes, I'm talking about, 2019 or newer boats. And so a lot of those boats do have fuel flow meters. We see fuel savings between 20 and 40%. And again, so let me kind of preface this with saying is that, let's say below 20 miles an hour, and you can see in the speed charts here, we don't see a significant performance gain until we get to about 20 miles an hour. And that's where we start to see the numbers increase. And then of course, at wide open throttle, you're not gonna, wide open throttle is wide open throttle. The boat's gonna burn the same fuel, effectively the same fuel at wide open throttle, regardless of whether it's got the foils or not. The difference we see is really gonna be a speed improvement. It may not be a fuel savings improvement, but it's a speed and fuel, it's a speed improvement at wide open throttle, but the main difference here is that we see is that, let's say between 4,000 and maybe 5,000, or even, it depends on the boat, but that's where we see these fuel saving between the 20 and 40%. So what we tell customers is basically, listen, throttle back on your boat, run 4,500, 5,000, you're still cruising at a nice clip in these cases between, around 30 miles an hour, a little over 33 miles an hour. And even at those rates, you're burning 20 to 40% less, depending upon the boat. And so, that's really, really substantial. The other thing that we've noticed in our testing, and this isn't accurately reflected in a lot of manufacturers' comparison. So like a lot of times, if you go out to a manufacturer's, test results, they always test when the boat is empty, or maybe it's got 1 or 2 people on it. And so what we've noticed with the hydrofoils, it's completely the opposite. So we see the most noticeable performance gains when the boat is loaded. So in other words, if you put, 5 or 8 people on the boat without the Hydrofin system, that boat's going to completely bog down, and you're basically going to have to put more throttle, to basically just keep that boat at a reasonable speed. Compared to with the Hydrofin system, the hydrofoils, they're not as affected by load. And so they work very well when people load the boat up. And so that's where we really see these higher number gains, right? So if you put 6 or 8 people on the boat and you compare the before and after, that's where we're seeing these higher numbers. So in the 30 and 40% performance gain numbers. So here's some visual pictures. These pictures are not edited at all. These are, us on the boat with me hanging off the front with a GoPro and a selfie stick to kind of extend the camera out in front of the boat. This boat in particular, so this is a smaller boat, but it gives you a good example. So this was an 18-foot sun tracker with a 60 horse Mercury command thrust on it. And this is wide open throttle. So both of these pictures are wide open throttle. And you can see that this boat just was not able to get up out of the water. Compared to with the hydrofoils, you can see in the back of this picture, here's the strut that I showed you previously. The hydrofoils are mounted. Unfortunately you can't see them, but they're right there. But basically you can see how much lift is generated from this boat before and after. And then again, this is just selfie stick. I'm holding it high up in the air to show before. You can see all the water spray and really how much plowing is happening compared to after in this picture. I mean, it's almost non-existent. All of that spray just simply goes away. And so that's how we're able to generate the performance metrics of these, that we just talked about before. So they're real, they're measurable, they're not fabricated. The hydrofoils work. So it's pretty remarkable.
That was like a calm day. I got a question.
Yeah, and this is a flat day for sure. And some days, when we're testing, we don't have the ability to, obviously control the weather, but that certainly helped in this picture. But there's a lot of videos that we've got on our YouTube channel. So if you go to just simply Hydrofin on YouTube, we've got probably over 30 videos of, customer testimonials, before and after videos, those kinds of things. And in a lot of those cases, it's with different conditions. This just happened to be, a fantastic illustration of what it looked like on this particular boat.
Yeah, I definitely agree. My question is what's stability on a rough day?
Yeah, so on a rough day, the hydrofoils are still going to help. And in fact, I would say probably, it's one of the greatest comments that we get is how smooth it makes the ride, even in rough conditions. Now, I tell people, I say, what you want to do, even in rough conditions, is still throttle back a little bit. It seems like the sweet spot, even for the hydrofoils. Again, it depends on the boat and the horsepower and whatever, but you want the foils to be active. So in other words, you want to keep the boat up on the foils. And typically that means that you're going somewhere between 20 and 30 miles an hour on the boat. And in that situation, the boat is basically going to ride right through the waves. The front of the boat is above the waves. And so it's going to be a very smooth ride. You don't probably want to ride wide open throttle, because even at wide open throttle, you're riding almost too high on the waves, and you can experience some cavitation of the foils if it's really, really rough. And so I just tell people, you're still going to get a better ride, but if the foils cavitate, it's going to lose a little bit of lift in between that chop. And so, so you're just not going to be able to stay consistently on top of it. So in every case, it kind of depends on how big the waves are, how heavy the boat is, all those kinds of things. And that leads to our next couple of slides here and talking about the location of installing these is really important. We want to make sure the foils are mounted as deep on the boat as possible so that so that we can get as much lift and so that we can minimize the cavitation that would be possible, especially in rough conditions. And so we'll talk about that in some upcoming slides here.
One other question.
Yeah.
Since you are reducing drag, obviously you're reducing the slip ratio on the prop. Are you replacing the props to get up to the speeds? Are you using the same prop that's on the original?
Yeah, that's a great question. I don't have that one in this slide. I need to add that one to this deck for the next conversation. But so I would say that probably 20 to 30% of our customers do choose to change props after the Hydrofin system because a lot of, especially on bitunes, we see that we just, a lot of bitunes, they'll put like 11 or 13 pitch prop, just for cavitation or for push reason. After the Hydrofin system, we typically will increase the pitch because the boat's going faster up to, typically I see a 15 pitch on this. And sometimes the diameter, might change as well. Since the stern of the boat is riding a little bit higher, we might see a little bit, we typically will see an increase in RPMs. We don't typically see cavitation issues, but we will see an increase in RPMs. And so that's why the customer might elect to change that prop out. If before, obviously, they're already running at their rev limiter or at the top of their RPMs, of course, that's when they might want to make a change on it. And so that helps them get a little bit better speeds anyway.
So we're going from like a 13 to 15 or 17.
Yeah, right.
What about lowering the end?
Yeah, so we haven't had any customers have to lower the motor itself. The prop, typically a prop change would solve that problem. So yeah, we don't typically see them having to lower the motor. What we'll do on average too is when we set up the system, again, we're trying to get most of the lift in the bow and not so much in the, we want the whole boat to come up, but we really want it focused on the bow. Okay, so let's talk about the solution here. It is a little bit different. Some of the specs are a little bit different. So this is our newer product. So we call this the Super Ride XL. This is made for tri-tune boats. And so as you probably know, so a lot of the tri-tunes now are getting really heavy. And so it's not uncommon. I would say the average tri-tune now is probably, probably close to 4,000 pounds. And it's not uncommon for us to see a tri-tune, especially some of the newer tri-tunes that have the fiberglass shells. They might have a fiberglass helm in front and those kinds of things. And so they're really adding, quite a bit of weight to these boats. And so we've had to redesign a new system to carry the load, and the curved plate, we've redesigned that as well to carry the load because the lifting force on these and the speeds of these boats are much faster. And so this system is really engineered for boats between, with average cruise speeds between 30 and 50 miles an hour. We do see, it's funny because, we see these customers, they might have, a 400R or something on the boat, and we talk to them and, their average cruise speed is really 25 or 30 because their wife, doesn't want to go any faster than that. It's not very comfortable. And so they're looking for efficiency gains and more lift at those speeds. And so we're able to sort of solve that problem for them. But so to be clear, if the boat's already going 50 miles an hour or 45 miles an hour, even in that case, we don't see, we're not going to see a 20% speed improvement on a boat that goes 45 miles an hour. We're typically going to see like a 10% or so speed improvement in a lot of cases. It's kind of 3 to 7 miles an hour. The manufacturers, the boat manufacturers, they put lifting strakes on those boats. They put bigger logs on those boats. They've done some other things to make them more efficient. And so it's more difficult for us to squeak out, a 20% gain. So on average, we're seeing, it is a 10 to 20% speed improvement. It kind of depends on the boat, but we also do see, somewhere between 10 and 30% fuel saving if that customer, in the sweet spot of, around, between 25 and let's say 35 miles an hour, if they're willing to sort of throttle back, we really do see that fuel savings on these boats as well. And again, just a smooth dry ride. So let's get into some of the technical aspects of, how and where we install these systems. So for pontoons, we've done this on enough boats that we ourselves have built a database. And so we pretty much know, so we've lifted all of the boats. You have to lift the boat to find the center of gravity, because that's what determines the installation location of that. And so for our installers, whether that's, a direct customer, or whether that's a boat dealership, or just a machine shop or something like that wants to install the Hydrofin system. So we've got the center of gravity metrics for most double pontoons. And so you don't have to actually lift the pontoon boat, but for tritoons, that is still new enough to us where, we've done probably about 50 tritoons now, but we're still lifting those to sort of find the norms on those boats. But the center of gravity must be found. And so, and on double pontoons and tritoons, the installation location, it's a little bit different. On double pontoons, we install the system in front of the center of gravity, but on tritoons, interestingly, especially the high-powered ones, we actually install the system a little bit behind the center of gravity, because there's so much power and torque on those motors that we found that, it varies a little bit depending upon the boat. And so in that case, it would be sort of, consult with our company, and we would provide the guidance on where to actually install it based upon that center of gravity. But the key thing on the boat for every installation, and this is a conversation that, we have to have with our customers. And this is simply, this is a change to the industry. And it's something that we're having to sort of work through with boat dealers and manufacturers and end user customers, is that, if customers truly want the best performance out of this system, if they want the best speed, if they want the best fuel economy, we've got to install these hydrofoils as deep as possible on the boat. And that typically translates to about 4 to maybe 6 inches worth of added draft to the boat. And so the draft, it's draft that's added to the bottom of the keel of the log itself. And so, the prop itself is running, let's say, probably 12 inches below the bottom of the keel. And so we're not as deep as the prop, but we're deeper than obviously the keel of the boat. It doesn't prevent customers from beaching their boat or trailering their boat, but changes to the trailer or to a boat lift may be required, depending upon the trailer and the boat lift itself. And so we'll kind of talk about that in an additional slide as well. But and I'll show you guys some pictures of what we've done in the past. But we've already talked about this, but the angle of attack dictates the lift force. So we kind of covered that one, but we definitely want the hydrofoils to be installed as deep as we can on the boat. Okay, so let's kind of talk about lifting strakes. And so there are other considerations. And again, this is something that we're talking with multiple manufacturers right now. The truth is, lifting strakes are controversial. And I say that because, from a manufacturing perspective, it's the best thing that they've got right now. It's not the best thing, but it's the best thing that they have. And so the speed and, the metrics around lifting strakes, they're all over the board. So it depends on, the size of the boat, the speed of the boat, the horsepower, all that kind of stuff. But just to make sure we're all on the same page. So this picture here, so, here's the lifting strake on the boat, right? So this is a piece of extrusion that they add to the boat. And so on most tri-tunes, they're adding them on the inside of the two outer logs. So, the basically everything that you see here, they would add these lifting strakes. What we've done on these boats, so I'm going to just kind of bounce between these two pictures. So on this bottom picture here, it's hard to tell, but this is the lifting strake. So this would compare to this green highlight here. So this is the lifting strake on this log. So here's the center log. Here's the keel of the boat. Here's the outside of the lifting strake. So we've got no problems with keeping the lifting strakes on any tri-tune. In fact, we want them to be there. They do add benefit to the boat. But what we've learned is you can see on this boat had lifting strakes. If you can see in the picture, there's kind of a line here where there was a lifting strake. And what we did is, we removed the lifting strake so that we could install our system, because as we reference on these charts here, the lifting force that we can generate with this system, for example, at 30 miles an hour, we can lift up to 1,400 pounds with this system. Well, a lifting strake, one little lifting strake is not going to lift anywhere close to what we can generate with our system. And so even though we remove the lifting strake, we're generating far more lift than what that strake did. And so this, again, a little bit controversial. The manufacturers are not yet crazy about this idea yet, but we are in conversations with multiple manufacturers. And I think that over time, COVID has kind of hurt us in some senses, because they're selling as many boats as they want to. They're on back order. You guys know the story. So they haven't had to get innovative and creative over the last couple of years. I think that over the course of the next year or so, they will. And so my suspicion is that, we'll get to a point where they will just not install these two lifting strakes here, and instead they'll replace those lifting strakes with our system. So, time will tell, but that's what we have to do. So we have to actually cut the strake and remove it. And that is a part of the installation process. So again, we still want to keep the lifting strakes as much as we can, because they do provide benefit. So we see a combination of, the lifting strakes plus Hydrofin. That's where, any boat is going to get the best performance and best experience overall. I'll pause for questions again here. We've covered a lot in the last couple of slides.
Are you going to talk about cost?
I'm sorry, what was that?
The question was cost.
Cost. Yep. So this system right here, so the system for tri-tunes it's $2,600. Basically, that's the retail cost of it. The installation price, it depends on if the boat's got lifting strakes and they have to be removed or not. But on average, the cost for a tri-tune is between $1,600 and $2,000 per install. So the total cost to the customer is roughly $4,200 to $4,500 to add this to the boat. For double pontoons, the total cost to the customer is around 4,000 or 3,900 to 4,000 for the double pontoon system.
Have you done anything with the boats that do about 70, 75 miles an hour?
No, good question though. So we cap this on boats that are right around 50 to 55 miles an hour. And the reason is the hydrofoils actually begin to cavitate at around 60 miles an hour. And it's not a limitation specifically of our hydrofoils. It's just a limitation of hydrofoils, just generally speaking. So Morelli and Melvin has done a lot of work and testing on this, and just, I mean, nowhere in the world have hydrofoils been, they just, it's a physics thing that they can't go over 60. They just start to cavitate. And so we limit our customers at around, 50 or 55.
Got it.
Okay, so let's talk a little bit about the trailers, and you can see here in this picture. So like I said before, the best performance is going to be gained if a customer, allows us to put this on, as deep on the boat as possible, which basically means if I go back to this picture here, the bottom of this curved plate, if you can see it, is going to be right up against the keel line of the boat. So it's difficult to see, but if this was the keel of the boat, we'd put our curved plate right up against the keel of that boat. And so what that means for a trailer is that we would actually remove a section of the wooden bunk on the trailer. And so that's what this picture is showing here. Structurally, it doesn't change the trailer or how the boat sits on the trailer. We simply cut, a piece of, this is, on most trailers, it's a 2x4 or it's 2x6. And, interestingly enough, too, in like 90% of the cases, the mounting brackets are actually right. They're perfect in a location where we can just cut the bunk, rewrap the trailer, and it's no big deal. The same is true on boat lifts. So we might have to, boat lifts are a lot of different size models of that, but it's not. But this is how we do most trailers here. And so it's, it's a 30-minute modification that we make to the trailer. If all we have to do is actually cut the wooden bunk and just rewrap it. So we've been doing some testing with a couple of different electric companies. And the test results are, they're comparable. They're really pretty encouraging. As you know, with electric power, there's a lot of battery weight on these boats. So we're talking about on, at least the ones that we've tested with and work with. So we're talking about adding, roughly 1,000 pounds or more of just battery weight, plus the engine. And so, but from a kilowatt efficiency perspective, there is a power curve, right? And that power curve is that the boat's got to be going fast enough to get up on the foils. But if it's going too fast, then it's just, it's burning too much energy. But it's somewhere between that 20 and 35 mile per hour range. That's where we see the highest efficiency gains. And those efficiency gains that we've tested, again, translate to, 10 to 25%. And so, these electric companies are getting, I think pretty excited about what we can do in terms of helping them, because that's huge, right? A 20% gain in terms of runtime on the water from a battery perspective is a big deal. So I'm going to pick up the pace here so that we can get through the rest of this, but just talking about the design process. So we looked at, a wide range of both double pontoon boats, tri-toon boats. What are the weights, the speeds, so that we could, custom make the foils for those loads and those speeds of boats. Morelli and Melvin looked at all the physical constraints. We looked at all different foil shapes and types, to look at how would the draft affect the boat. How would the center log look at boat? What are the structural limits of the logs themselves? Because if you go back into the boats that were made in the 80s and 90s, the whole thickness of the logs was different than what it is now. And so we've designed this to work on boats, from the 80s and 90s, where those boats weren't quite as structurally strong as what they are today. So we basically overbuilt the system. So Morelli and Melvin, they've got, all kinds of specialized, software applications, CAD tools that basically help them determine, the span, the cord length, the shapes and everything to really optimize the foil design itself. And they've looked at structural analysis. And so they've done, so here's a chart, and this kind of goes back to what we were talking about earlier. But so this is two boats, right? One with foils, one without foils. And what's the drag comparison at different speeds? And as you can see, we're not getting any benefit. So the orange one here is with the foils. The gray one is I'm sorry, that's in reverse. So the gray one here is with the foils, the orange one's without. But what are the speed and the efficiency gains? And you can see that once we get up into 25 miles an hour, look at how efficient this becomes all the way up to 40 miles an hour. And so, here is that sort of power curve that we look at, which most consumers, we think, are using their boats. You've got some that are running at that wide open throttle, but if you can just throttle back, here's where that power curve really, really benefits the customer. So going back to some of the structural analysis and whatever, so here's the curve plate and some of the simulations that they created to look at, what's the load on the log. And this is with a log that is a 0.080. So this was the, sort of the thinnest logs that they make, but to make sure that the stresses caused by the lifting force don't pinch or, make that log basically, crush the log, if you will. And so we've done all the structural analysis to make sure that that's not going to happen. We've also actually created fail points within the design of the system so that if there were a sudden impact, let's say, somebody grounded the boat at, 30 miles an hour or something like that, and it happened to hit the foil first, or maybe there's a submerged log or something like that. So we've got shear pins within the system itself that would cause the foil actually to break off before it broke or damaged the log itself. And so we've got fail points designed within. And so on this point, it's right here. And so we've all built and designed, we know people are going to hit stuff. And in fact, we've had a lot of customers report back to us who have hit, various objects, some seen, some unseen. We haven't had any failures that were catastrophic to the system or to the boat. We've had to replace a couple of designed replacement parts, but that's only happened in 2 cases. And that's over 200 boats that we've got out there. So just talking about, the installation process, this is obviously a streamlined kind of step process, but, it's really finding the surface. It's finding the center of gravity, marking the center of gravity and the trailer. Oh, I'm sorry. Was there a question?
I've got, yes.
I'm sorry.
Computer.
Do I still have you guys? Can you guys still hear me?
Yes, you're back.
Okay. So, it's really not super complex. It's basically finding the center of gravity, marking that location, marking where the plate is going to go on the boat, doing the surface prep. We currently, with the structural adhesive, we actually use just basic ratchet straps. We've got to get the boat off the trailer to get the straps around the trailer, but it can be done like we've done here. We've just jacked the boat up, wedged some, blocks of wood between the trailer and the log just so that we could get the straps between there. Glue it to the boat and make sure that the angles and everything are set. And then basically the foils just screw on to that large curved plate, and then we hang it to the top. So like I said, it's 5-6 hours and we're done. So we've covered this. Will it work with trailers? Yeah, there's modifications to the trailer or to the boat lift. We haven't talked about this too much, but can I still beach my boat? So the foils so typically the center of gravity, it's about 2/3 of the way back from the very front of the boat on average. So they're really far back on the boat. So even if you're drafting, say 4 or 6 inches, and you're beaching your boat, where the foils are in the water compared to your beached boat, you're still probably in 12 inches of water. So it's something to be mindful of, but it hasn't prevented any of our customers from beaching their boat. And by the way, if a customer is concerned, and we have had a few customers, particularly like in Florida or in some coastal towns where there's sandbars and whatever else, if they don't want it to draft any deeper than the boat, then we just we set it up where it's equal with the bottom of the boat or even a little bit less. And so we just explained to them, it's going to take away a little bit of the performance. It's not much, but we can do that and it's not a problem. What if I hit something? That's a super common question. We kind of talked about that. The system is designed to withstand a sudden impact up to 3,000 pounds. And, if it's above that, it's going to break off. If it's below that, it's probably going to either stay in place or it might bend apart, a replaceable part, but, not a big deal. Whoops. So grass and weeds, we get that question a fair amount. If a customer is in an area where there's really thick, heavy grass, we recommend, and so our system, the Superfly XL system, which is what we put on tri-tunes, we can also install that on double pontoons. It's not a problem. The reason why we might suggest that foil system has got a swept wing design. So the leading edge of it is got a curvature that won't catch weeds and debris, and it'll just kind of brush right off. And so if weeds or grass is a concern of the customer, then we'll just switch the product over to the Superfly. The Super Ride XL product. So that's everything that had. A lot of information out there on YouTube, customer testimonials, videos of the boats running, all that kind of stuff on our website, also at shop.hydrofin.com. But I'll open it up to questions. Are there any follow-up questions?
Yes.
I might have missed about what material did they use to build the fin with, the foil?
Oh, to build the foils, what's the material? What's it made out of? Okay, yeah. So what we've done is we've gone through the painstaking and costly effort. We're actually getting these parts die casted, and so the tolerances are very tight on these hydrofoils, and the trailing edge it's very thin, and that's just a part of the design requirements. And so we had to get these die casted, and so they're cast actually in aluminum. It's an A356 cast aluminum, and it's heat treated T6, and then they're anodized as well. And so that's all of the parts. The curved plate is actually, it's a rolled aluminum, and it's 6061 T6, but it's all aluminum.
Is the fin solid or?
Yeah, they're solid casting. Yeah. So for example, one of the wings is, being that it's a solid cast piece, and they're about 2 feet long, 24 inches long, with a cord length of about 9 inches. And so they're about 12 pounds each. they're pretty solid.
Jason, as they're anodized, is there a special anti-fouling coating needed?
No, no. I mean, for certain customers, you know, on the hydrofoils themselves, if a customer is going to keep their boat in salt water specifically, you know, we might recommend to them that they actually bottom paint the hydrofoils. Prop Speed makes a really great product that is engineered for props and foils, and we do recommend that. It's you know, for the foils themselves, not for their remaining components, but it's not a requirement. But I mean, if people are going to keep their boat in the water, I mean, it's you know, they will get growth on the foils.
Jason,
Yeah.
I have a question. Since the your hydrofin is only on one side, the inside of the pontoon, do you have any issues about extra or added torque to the pontoon itself?
In terms of like twisting kind of torque or anything like
Yes.
that?
Yes.
No, because the way that we've structurally engineered it, where it also mounts to the deck of the boat, we haven't had any issues with that. Our engineers, you know, tested all of that. And of course, we've done all the on the water testing. We have had zero issues with that. One thing that it does do, I don't think I mentioned this, is as a benefit actually that's sort of related to this comment. It actually helps the boat lean into the turn, which most double pontoons and even a lot of tritoons don't do. They run pretty flat in a turn. And so it actually, because we're actually intentionally installing the foils at a downward angle. So the dihedral angle is sort of a downward, about 10-degree angle. And so in a turn, that helps the boat lean into the turn, which makes it more comfortable to the passengers, but it doesn't negatively stress the boat in any way.
Jason, what material are the fasteners that screw onto the curved plate?
So all of the fasteners we use are stainless steel. All of the fasteners, the pins and the hardware.
What's he using for a shear pin?
What is the shear pin made of?
It's made out of stainless steel as well. So basically what's going to happen on the shear pin, so the cast aluminum is going to break at the shear pin.
Questions, guys? I think that does it, Jason.
Perfect.
Well,
Sounds good. Well, hey, thank you so much for the opportunity. Grateful to, you know, wish I could be there and meet you guys and whatever, but yeah, my number and everything is here if you have any follow-up questions. Thanks so much.
And Jason, if I can just add my thanks, Mike Schwartz from IMS, very much appreciate you speaking. Thank you very much indeed.
Yep, absolutely.